Hi, Integrated Math 1. Welcome to lesson 1.1.1b. We're doing day 2 of exam understanding quantities and their relationships. We probably won't need the scissors and glue tape today, glue stick tape stuff today, because we did that last time. We're actually going to be playing with those this time. I know I still have it on my screen. Sorry. We're coming back to the warm-up. We do have a warm-up. You did the question number 1 on the warm-up before. We're doing question number 2 this time. We talked about how Emma bought a new video game. The graph shown describes the number of hours Emma spent playing the game over a period of 7 days. And last time we labeled our axes. So we said the x-axis was the time measured in days, and we said the y-axis is the time playing the game measured in hours, right? Because the amount of time she spends playing the game depends on on what day it is, right? She'll probably play a lot more on Saturday than she could when she has to go to school on Monday. Fair enough. So today's part of the warm-up that I would like you to finish off. What does the highest point on the graph represent with respect to the scenario? And what about the lowest point? Go ahead and hit pause and jot down your thoughts on this in your workbook, and then hit play when you're ready to keep the discussion going. All right, so I'm noticing my highest point is this guy right here. And I know the coordinates of that are 3, 4, because I had to go right 3 and I had to go up 4. So the highest point, 3, 4, that's on the third day she played 4 hours of video games, didn't she? So the highest point, 3, 4, represents that Emma played video games for 4 hours on the third day. Yes, she did. Well, what about our lowest point? Now, I don't know if you noticed the lowest point because there are a lot of points here. This is the lowest point. Look at that. Did you catch that point down there? Like way down there on that 7th day? Yeah. So that looks like we had to go right 7 and we didn't go up at all. That's a 0. So the point is 7, 0. That's the lowest point. And it represents that Emma did not play video games on the 7th day. Maybe she got in trouble, or maybe parents just told her she couldn't play that day. I'm not sure. But we get the idea, right? Now that we know what our x-axis is, now that we know what our y-axis is, when we look at a point, this tells us things, right? This gives us information. And again, that's why we like graphs, because we can see the information. It's a lot easier than if Emma just told us how much she played each day, right? That's kind of lame. I like the graph. I can see what's going on here. So again, we're understanding quantities and their relationships. Again, our learning goals, understanding quantities and their relationships with each other. We played with that last time. Identify the independent and dependent quantities for a scenario. We played with that last time. We want to match a graph with an appropriate scenario. We played with that last time. We also use a reasonable scale for a graph modeling the scenario. That's where we labeled our x-axis, we numbered our x-axis, and we numbered our y-axis. We did that last time as well. We're going to focus a little more today on identifying key characteristics of our graphs and describing similarities and differences between these graphs and their scenarios. What makes them the same? What makes them different? So our key terms from last time were dependent quantity and independent quantity. Just to remind ourselves about these guys, so we've analyzed these graphs, we're looking at these important features, and we're going to continue saying, hey, how do these key characteristics of the graph tell a story? That last graph on the warm-up, right? The maximum told us, hey, on the third day, she played 4 hours of video games. The minimum on the graph told us information, right? On the 7th day, she didn't play any video games at all. But these key terms, dependent and independent quantity, just to remind ourselves, when one quantity depends on another in a problem situation, it's said to be the dependent quantity. The quantity that it depends on is the independent quantity. And if you remember from last time, we said the independent quantity is what comes first. The independent quantity is always what comes first. So in activity 1.1, we were matching up our graphs with the appropriate problem situation. And what we're going to do now is we're going to do activity 1.2. We're on page M1-14. And we're going to go back. So you are going to be flipping back, right? All those 8 scenarios that you did, and you match up all the graphs, independent, dependent, and you labeled all your graphs and had everything going. we're going to go back and examine those now, okay? We'll write our findings on these pages on page M1-14, but we're going to flip back to the others to take a look. So what I want you to do first is I want you to go back. I want you to take a look at all the graphs that you glued in and matched with your scenarios. And I want you to tell me, write down, what similarities do you notice in all of these graphs? And I have all the graphs over here just as a point of reference while we're talking. So what similarities did you see as you flip back through all of your scenarios from earlier? Go ahead and hit pause, jot down some notes, and then hit play when you're ready to keep the discussion going. So some similarities that I noticed. I noticed that every single time that we did these scenarios, like remember how we wrote the independent quantity and the dependent quantity, and then we did the graphs? I noticed that every single time the independent quantity is graphed on the x-axis, while the dependent quantity is graphed on the y-axis. I suspect you may have noticed that too yesterday. I noticed that all the graphs are continuous. And when I say continuous, that means they're all connected lines and curves, right? The warm-up we did wasn't continuous. The warm-up we had was like a dot, 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 dot. These graphs aren't dot, dot, dot. These graphs are continuous, right? We've got continuous lines, all nice curves. The lines and curves are all connected. No dotty dotty here. So now the question is, what differences did you notice in the graphs? Go ahead and hit pause and again, flip back through, jot down your the differences you see, and then hit play to keep the discussion going. So there are definitely some differences. I noticed, one of the first things I noticed was that some graphs contain straight lines and some graphs have curves, right? Nice soft little curves, right? We've got some that are curvy, like graphs B, D, and F. And then we had graphs that were just like straight lines, like A, C, G. These guys are like straight lines. I also noticed that some graphs seem to move up as we go from left to right. Some are going up, and that some move down from left to right. We call that increasing and decreasing, by the way. So some were going up, some were increasing, some were going down, some were decreasing, and some did both, right? We had all kinds of stuff. So some graphs are made up of pieces that go up, go down, or stay constant from left to right. I got all kinds of stuff happening here. You probably already know the answer to question number 3 because we kind of already discussed it. How did you label the independent and dependent quantities in each graph? Go ahead and hit pause, jot it down, hit play to keep going. So we noticed earlier that our independent quantity was always on the x-axis and the dependent quantity was always on the y-axis. So that's a great thing to know, right? That's an awesome thing to know. That means your independent quantity is always going to be the label for your x-axis and your dependent quantity is always going to be the label for your y-axis. That's super, super handy as far as knowing how to label your graphs, right? That's a pretty cool thing to know. Question number 4, analyze each graph from left to right and describe any graphical characteristics you notice. Just a real quick note, we said earlier when we looked at left to right, we said if it was going up, we said it was increasing. If it was going down, we said it was decreasing, right? So up is increasing, down is decreasing. I think that's facing the right way. That's good. So that's kind of what it's asking you about. What do you notice about increasing or decreasing? On our warm-up, we were asked about minimums or maximums. Do you notice anything about minimums or maximums here? High points, low points? Go ahead and hit pause, jot down just what you notice about these graphs, and then hit play to keep the discussion going. So I don't know about you guys, but I made a lot of notes here. I noticed that some graphs only increase, right? Graph B, that bad boy's only going up. That's all it's doing. I noticed that some graphs only decrease, right? Fair enough. Graph D is going down. Graph H is going down. I noticed that some graphs did both, right? Graph C decreased and then increased. I noticed that graph F increased and then decreased. It went up and then it came back down again. I noticed that some graphs have a minimum or a maximum, right? The baton twirler, there's a maximum height, right? That's as high as the baton goes. That's just how it is. But even our jelly bean example had a minimum, right? The minimum is 0, right? If you guess spot on, you're not off by any jelly beans. And so had a minimum of 0. Some graphs increase or decrease at a constant rate. If it's a constant rate, it's not going to curve. So I noticed graph H decreased at a constant rate, right? I noticed that graph G, even though it did stop in the middle, stupid scale left, it did stop in the middle. I noticed that it was a constant increase, and then we got stuck on the ski lift, and then we constantly increased again. Theoretically, we got to the top of the hill so we could go skiing. That's the dream anyway, right? That's what we hope for. All right, guys, good work today. As always, I hope this was helpful. I hope this was useful. If you have questions or concerns, again, email me, come see me during office hours, come talk to me. I'm usually pretty nice, usually, most of the time, some of the time. Anyway, guys, thanks for all your work, and I'll see you guys later. Bye.